Hello viewers, this is engineer Sadaqatali and you are watching my YouTube channel Real Time Simulation World. So in this video I will discuss with you that how I designed grid tied inverter control and monitoring in LabVIEW Multisim core simulation. So let me run this code and discuss with you that what is basically a grid tied inverter. So a grid tied inverter is basically an inverter which either takes power from the grid or injects power into the grid. It can take and as well as it can give power to the grid. So this is my overall uh, look of the front panel, right? My code is running. So I have designed this control in LabVIEW and the circuit is running in Multisim. So this is how LabVIEW Multisim core simulation is working. Uh, Now in my uh, this setup, I am basically measuring grid voltages, the voltages that are coming from the grid, inverter current, the current that is fed back from the inverter, carrier and reference waveform. I have simply used here WM technique. These are my three-phase reference waveforms and triangular waveform. Right? I have kept the carrier frequency to 2 kilohertz. Right? Moreover, I am measuring the phase voltages and currents as well. You will see the graphs very soon. These are different parameters like in order to control the power of going into the grid, you basically need to control certain types of currents like you have a direct direct current, quadrature current, ID and IQ we call them. So I am just measuring those here. These are again uh, some voltages and some currents. This is my output voltages of the inverter. So you see pure sine wave, pure output sine wave, a little transient during the startup. Let me show you my block diagram because it is very necessary to show you guys how the block diagram looks like. This is my complete block diagram of this grid tied inverter. What I am doing, taking the grid voltages and inverter current feedback, they are feedback, right? And then I am taking the grid frequency for the phase lock loop. For the phase lock loop, I am transforming the three phase voltages and currents from ABC to DQ. I am using ABC to DQ transformation, and then I am utilizing those direct D and quadrature components control active and reactive currents respectively. These are my PI controllers, current current reference and to current reactive current reference simultaneously, right? And then again after this I am converting back to DQ to ABC, right? And here there are three sine waves for my three phases, right? I am using a triangular waveform as a carrier. I am comparing those and generating my control signal to operate my three phase inverter. So this is how my uh, uh, block diagram of code looks like. So you can see here grid voltage and the inverter output is identical, same, and in phase. This is my inverter current that I am feeding into my grid. You can also see the carrier and reference waveforms, right? You can control the frequency of the carrier. Let me reduce it 1500. So you see my frequency is reduced now compared to previous one. If you reduce the frequency, your the shape of your voltage or the pH of the current increases a